everybody, it is Leslie Denson and Kenny Gorman over at Eventador. We are really excited to get started with a new series for you guys today, which is the Eventador Streams tutorial series. We've been really excited and have really enjoyed the podcast of Eventador Streams that we've been doing and will continue to be doing, where we talk about all different aspects of streaming data, how people are using it, bring in folks from across the streaming data industry. But we wanted to take things one step further for you now and actually put into action and show you tutorials for how to do certain steps and certain activities and certain things that we've talked about in the podcast or will be talking about in the podcast and just in general using the Eventador platform. So super excited to get started with this. You can expect to see videos from us every couple weeks as we have something new to show you. And always feel free to reach out to us as you have questions about any of these. So, hey, Kenny. Welcome to the
Hey,
video.
thank you.
So today, what we're going to be talking about is the REST Producer API and why that can be really important for folks either as they have Kafka or maybe they're just kind of getting started and don't have Kafka set up just yet. So enables organizations to really easily ingest and use streaming data, and wanted to give you guys a quick demo on how you actually use it. That sound good?
Yeah, let's do it.
Awesome.
All
Okay,
right.
you officially have the wheel.
I have the calm. Okay, so let's talk through this a little bit. So first of all, so like as Leslie said, we're going to be talking about the REST Producer API. And we created this API because a couple of reasons. One is maybe you don't have Kafka yet. Maybe you're just playing around and you're learning and you're trying to understand stream processing and how do I work on streaming data. And maybe you don't have something like Kafka or Kinesis or something like that you can immediately connect to. So whether you're in like a development or a discovery cycle, or maybe you're using a piece of code that is going to go and pull data in, but you don't want to deal with the complexities of Kafka. It's just something, the piece of infrastructure you don't want to have just in order to run queries on streaming data. And so the REST Producer API allows you to kind of have that function out of the box. So for us, it makes examples easy because we don't need you as the user to have a Kafka cluster. So that's nice. But beyond that, if you're just writing simple Python code or something like that, or even curl, and I'll show some command line examples here in a second, the Producer API makes it super simple to put data into Eventador and then start running queries against that streaming data. So on my screen here, I've kind of have a real high level architectural diagram of what we're going to go through today. This is in our docs. So we have every one of these tutorials will have a kind of doc page that goes with it. And in this case, you can go check it out. Go to docs.eventador.io and click on examples. And it's listed there. So let's kind of so this is what the flow is going to be like. What we're going to do is we're going to, in our case, use curl, the command line utility, to produce data to the REST proxy. The REST proxy is the Eventador REST proxy, not anybody else's, because there are some popular ones out there. We wrote our own that works with our system. And I'll show you some of the API calls. They're pretty cool. It's going to actually then produce that data to an internal Apache Kafka cluster that you don't need to worry about. It's completely fully managed, and it's completely encompassed in the Eventador system. And so you can just produce data to it to your heart's content and manage it within that system, and then as well as connect to any other Kafka cluster. That we didn't remove that capability, obviously. And then it allows you to then run ContinuousSQL or run Flink jobs directly against that stream of data. And I'll show you how to discover the schema, how to produce data, how to discover the schema, how to build a virtual table, and then run some SQL. And then in our case, we're just going to produce it out to materialize it into Materialized View. And then I'll show you how to query that downstream. So, just to kind of recap, the important piece of ContinuousSQL, the reason that that's so compelling is, number one, is it allows you to query streams of data with SQL. So that's cool. But kind of in a bigger picture, whenever you're processing SQL continuously against messages, you're living upstream of maybe any databases or database infrastructure that may exist in the enterprise. And therefore, you're saving cost, you're saving query time, and you're saving pieces of infrastructure that you may or may not need. So, the reasoning kind of behind our thinking here is, most people, or at least a very common use case, is to take a Kafka stream of data, to sort of, to use a lack of a better term, drain that data into tables in a database and then run SQL against it. And while that's popular and kind of easy, it really sucks because you have to then have an index pattern or have indexing correct. You have to, if there's a lot of data in there, and gee, most streaming systems produce a lot of data, then your database is going to be quite big and large. It's slow, and it's a lot of infrastructure to manage and pay for. So in a lot of cases, it's just easier to query the stream directly. And so that's what we're going to show. We're going to show you how to produce some data, how to then run a query on it, and kind of go from there. So
Nice.
Let's jump in.
Let's do it.
Okay, so we're going to go to the Eventador console, and a couple of things is, and I've skipped a couple steps here just so I'm not exposing my keys, but I've gone ahead and I've created some keys, and the way you do that is, you go into a cluster, you choose to manage API keys. In this case, I've already added this key called XX just for a sample to this cluster, and then I have a base URL. So the base URL and the key, the API key right here, are the two components that you're going to need ahead of time to produce data to the API. So that's two things you do to kind of set up. So I've already done that. And I've also set those on the command line. So that part's already done. So let's go ahead, and I'm just going to copy paste some of this stuff. And let's just go over here, and let me change myself to a terminal. How cool is that? And just run a curl command. And so what we're looking at here, let's just talk through it real quick, is I'm posting via HTTPS to this base URL, which I told you I already set. I'm specifying my API key. I'm saying that I'm posting JSON data. Okay. And what I'm doing is I'm creating a topic called temperatures with 3 partitions, 1 replica, and then I'm setting retention bytes. So you can set whatever Kafka configurations you want. Okay, so super simple. You run that command, oh, it already exists, perfect. And there you have it. You have a topic, if it wasn't already existing, that you can run. Live demos are always fun. You can run queries against. So that's step 1. But let's see what topics are already there. So I'm just going to go and paste this command. So what I'm doing here is I'm just getting the list of topics and specifying the API key. Actually, let's put it through JQ. If you don't use JQ, you're silly because it's awesome, but here, just check it out. So I've got a couple of topics here. So I have one called telemetry, I've got default sync, I've got temperatures, which we would have just created, the stock Eventador one called EV sample fraud, and then one called temperatures 2. So that's what all my topics look like. It's easy to kind of create those. So now let's just push some data in there. So let's just paste this in here and talk through what this is. So kind of similar to the other one, I'm going to, again, post some data to the base URL. In this case, the topic temperatures is in the URI. I'm going to specify my API key, that it's JSON data. And I'm just going to send an arbitrary JSON data, a piece of JSON data in there. So in this case, sensor 1, temperature 33 degrees Fahrenheit. And I send that data and it pops it right into that topic. And so maybe, just up arrow, and maybe it's, sensor 2 is 34. So I'm just making up some data here. And maybe sensor 3 is, 40. Okay, so just pushing some data in. Right. That's simple. I'm producing data to Kafka. All right, so that's the easy part of it. We're just pushing that data in. Now that could be done via Python API, anything that can basically support HTTP post or GET, the basic REST protocol. That's basically everything on the planet at this point. So I'm using the command line, but it's super easy to write stuff in Java or Scala or Python or Ruby or whatever. So just kind of give you a feeling for that. All right, so let's go into Eventador and what do we get and how do we make use of it now? So I'm going to go over to the Eventador console, and I'm going to go to Stream Builder, and what we're going to do is create a virtual table. Let me zoom out a little bit so you can see that. I'm going to create a virtual table for this particular topic. So I'm going to add a new source, and I'm going to name it temperatures. And I'm going to pick the cluster that we sent it to, that I created the API key for. We're going to pick that particular topic. It's JSON data, which we saw, I posted that when I posted the data. And then we're going to go ahead and detect the schema. So this is cool. So the way this works is it automatically goes out, reads the data, does a heuristic, figures out what data types have been presented, and then builds you a dynamic schema. So this is killer utility, especially if you don't know what kind of data is being put into topics. This is also very cool if you have other people pushing data into topics and you're kind of self-serving
Right.
solution. So that works nice. So in this case, we've got the sensor name, the temp, and the unit of measure. So and that we inferred it. So that should look a lot like the thing I sent in. It automatically did that for me. Didn't have to do anything. And so I saved that, and now I can go over here to the window and I can just describe it. So temperatures, and sure enough, I have the schema that I said. Now, one thing I want to point out is because it's Kafka, we have the magical Kafka timestamp, and we can use that timestamp in our queries. So one more thing, let's talk a little bit about Materialized View, and then I'll run the query and we'll kind of get some output and we'll talk through it. So what's important is Materialized Views are the ability so ContinuousSQL runs all the time. If it's running all the time, it's kind of hard to consume it in modern tooling. Maybe you're in a notebook, maybe you're like running it in Power BI or some sort of user interface. Those tools expect queries to end. And so what we do is we materialize the results of a stream into a materialized view, and then we allow you to consume that via REST endpoint. So that makes it super easy for you to, make sense of things coming through your streaming data. So let's just do it here, and I'll show you. So let's run a piece of SQL, and let's talk through this. Just copying it from the examples. So okay, so I have a piece of SQL here. What I'm doing is, let's just talk through it. I'm creating a window of 1 minute, a tumbling window. I'm using event timestamp. So that's the timestamp that was assigned when I wrote the data automatically into Kafka. So I didn't have to specify timestamp. If I wanted to, I could specify that and I could use it as well. But in this case, I'm just going to use the Kafka one. I'm saying from temperatures, which is the virtual table that we just set up. And then I'm grouping by tumble. All right. So this is a pretty simple query. I'm averaging temperature over a 1 minute window forever, never ends. Couple things to point out here. Because this is SQL Stream Builder and because this is a Flink job, if we're averaging temp over 1 minute and this job crashes or the cloud nodes go away or whatever happens, and there's some failure, this job will pick up wherever it left off. That means it will not have to reread the 1 minute of state that it already had captured. So where that's important is if this was an hour or a day or a week, it would not have to reread and restart and redo all that data. It would instantly pick up from where it left off. So it's a very important point and a cool feature about SQL Stream Builder in general. Okay, so I've got that configured. Now I'm going to configure my materialized view. And in this case, what I'm going to do is I'm going to pick timestamp as my primary key. So that means it's going to upsert the temperatures by that primary key. Okay. And then let's give that API key that we did before. And let's just build a quick query endpoint here. Let's just call this temps. And I'm going to select all of the columns. I don't need any filters, and I'll save that. So now I have a API REST endpoint. I'm going to go ahead and copy that address, and I'm ready to run that. So, okay, let's go ahead and start it. I'm going to execute that query. So it's building the job. What's cool about this is if I would have gotten the SQL wrong, so it obviously parsed. If I would have gotten the SQL wrong, then it would have told me immediately and I could correct it. It's not like when you're running a stream processing job in Java where it's a string and you won't know until runtime if it failed. This evaluates it immediately. Then it deploys it out to the Flink cluster. So it's if I would have selected some level of parallelism, it would be running it in parallel. In this case, I'm not. In this case, I'm just running it as a single thread, and it's running in the background. Now let's go over, start sampling the data here. So let's just go ahead and use that REST endpoint. We're just going to curl that. So let's run it through JQ again so we can see it better. All right, so what we've done is we've basically now are averaging the temperature over a period of time, right? You saw this data come in, and it's by timestamp. So every one of these timestamps is a primary key. And then we have the average temperature for that period. What's super cool about this is not only am I taking streaming data and returning a simple result, I've also made it very easy to consume in something like a Jupyter Notebook. In fact, let's just go over and do that real quick.
Yeah, that's what's so cool about this and what I appreciate, and I think people, when they actually see it in action, appreciate, is that there's no need for you don't have to go through a database. Your data isn't old, or you haven't tried to. There's so many different things that you can do now that you're not running this through a database where you just have that API and you can send it, that make
Yeah.
it super usable and so much easier.
Yeah, the thing I should point out that might not be right, you make a good point. The thing I should point out that might not be obvious is those results were instant. Like I didn't
Right.
wait for a query for a minute or whatever. It just happened because it's happening in real time. It's operating against a stream. So it's kind of that simple. So okay, here's what I done. I jumped over into a notebook and I'm going to use Pandas. If you're not familiar, Pandas is a data processing library in Python. It's often used in data science. It's a pretty cool and useful library. And it allows me to serialize JSON output into what's called a data frame. So let's just run that data frame, and you can see, boom, it spits out the data just like you saw in my terminal, but in a nice format. And now it makes it super easy for me to make graphs, to power dashboards, to build analyses and things like that. So that's it. That's end-to-end producing data via curl, going into SQL Stream Builder. I'll point out that we have a running job that's always running here. Let's go over there and show you. So like right here, 2 minutes ago, I have this job practical cray running, and
Right.
it's just always doing that. It never ends. I can see logs about it and what's running. I can see the capacity remaining on my cluster, things like that. So super easy way to get started with stream processing, super easy way to start running SQL on streams without a lot of hullabaloo. You can mess with and compose different SQL if I wanted to. Let's just do this real quick. If I wanted to edit that, and let's say I want, so stop the job, and let's say I want to show you this. Let's say I got it wrong. Let's say I said, I got select wrong. If I want to run that, it's going to give me, and it's going to tell me what happened.
Yeah.
Maybe I got the column names wrong, right? This is a very common one, right? Maybe I just got typoed that, right? So it tells me that column's not found. So this kind of it seems almost trivial, but when you talk to a user, and they're like, hey, I'm kind of blind. I don't really know what the table looks like or how to create SQL on it. You have to be able to describe it. So I showed you that. And get the data types, and then you want to be able to author,
Yeah.
and start to build from there. And so you can iterate and build statements from there. So that's the really that's it. That's end to end. It's pretty simple. So we created some data via curl. We put it into the REST endpoint. And that goes into a scalable and production quality Kafka cluster. Let's go back to the diagram here. We ran some ContinuousSQL on top of Apache Flink with all the durability and scalability that we talked about. And then we easily created a materialized view and popped it into a notebook and was able to then, if I wanted to graph it or whatever, I could easily build it from there.
Well, and to put a fine point on some of the stuff that you've said during this as well, is if you're somebody who works with Flink or works with streaming data, it opens up what you can do with it. It makes it easier. There aren't as many steps, quickly running a Flink job with SQL. But if you're somebody who's just starting out with streaming data and you don't necessarily have Kafka, or if you're somebody who's sitting in a data analyst role and who's trying to build a real-time dashboard, or
Right.
somebody who's trying to build a model who maybe doesn't know what they have in Kafka, just knows that they have 1,000 sensors, call it an IoT company.
Right.
They have
Exactly.
1,000 sensors out there and they're like, I'd really love to be able to create some sort of dashboard out of this, but I can't get access to this. This is the
Right.
way I see this. And I think the way, we've talked with people about this before, is it gives them some visibility that just previously wasn't really there, easy to get access to. Would you?
Right. And I can show you, so if you want to go here, let me show a couple examples of this in practice. So in this case, I went to the Eventador examples for fraud. It's in the GitHub repo for the Eventador examples. And if I just look at here, I'm using Eventador.py to actually just produce data so I'm using Python now instead of curl.
Right.
And I'm pulling up some variables from the operating system. And then I've got some higher level methods here, like create a topic or produce data, that kind of thing. So it's super easy to write with just a few lines of code, the ability to produce data to Eventador directly. And then if I go back to the docs, you can go down to the Eventador API, so docs.eventador.io/API, and that's the docs for the whole API. So super simple to get started and play with. Maybe you're doing it in some other language, then you can just get started here. And in Python, obviously we use the requests library. On the command line, we obviously use curl, but every language has its own capability to manipulate REST APIs. And this is just a start for us. So this is producing the data is the first step in a long API roadmap. We were able to consume from the Materialized View via API, and we're able to produce to the Eventador system via API. But we've issued the SQL in our UI. All of that is going to be exposed to APIs going forward in the next few sprints. So over the next month or so, you'll see a lot of new features come out that allow you increasing levels of command and control over the entire cluster and the entire system, the entire platform via API.
Nice. Well, and if you want to get started, you want to try it out, as Kenny mentioned, all of these examples are in our docs. I'll also link that in the description of the video where you see it here, so you should have easy access to it. And if you want to get started, you can always sign up for a free trial at eventador.cloud/register, or you can always reach out to us. I'll throw our Twitter handles up here again in just a second, or you can reach out to us at hello@eventador.io, and we are happy to help you get started and see what you can do with this. So
awesome. That was fun. Thanks, Leslie.
yeah, thanks. And we are, like I said before, we're going to be doing this more and more. You're going to be seeing more and more tutorials for us. So if there's anything that you've seen that we do or anything that you've heard us talk about, please feel free to reach out. We'd love to hear from you what you guys would like to see, how the Eventador platform can help you work with streaming data, what any of the features are. Happy to walk through any of those. So we always love hearing from our listeners. So don't hesitate to reach out.